A very good morning, students. So here I am with the answer to the question that we have discussed in our previous session. I hope you remember all of them. So the question with which I ended my previous session about Earth and magnetism was about aurora, right? Very beautiful and distinguished phenomena. So I'll show you some of the images that I've got, and while showing the images, I'll explain how does the magnetic field of Earth plays a vital role, or rather, the most vital role in formation of an aurora. So you see, many of you must have seen this. This is what is called the phenomena of aurora borealis. Okay, and this is how it looks like. I know it's stunning. Okay, now you can see that there are plenty of color frames. Here the green color is there, like somewhat greenish blue color. Okay, the red color is present over here. Somewhat pinkish color is present over there. Somewhat light green color is present over there. So all these color frames are being formed, and why they are formed. Let us try to understand this in a very short video that will be framing over here. Okay, so now if we look over, let me just erase this. Okay, so if we look over the Earth's magnetic field from a spectrum point of view, okay, so this is how it basically looks like. Now this image is a very famous image, and you must have seen these images all over the internet, right? So this is where the Earth is. Okay, let me highlight you. This is where the Earth is, and you can see the magnetic field lines, the representation or the simulation coming out from it. Okay, so we can depict it in this manner, that since this part, it's a very basic revision of the previous video also, if you remember, since this part is the geographic north pole, so that means it corresponds with the magnetic south pole. Yes, that's correct, magnetic south pole, and therefore this part would be the magnetic north pole, right? So as we have learned in our first video that the magnetic field lines runs from north to south outside of a magnet, so this must be the direction in which these field lines are going, according to that theory, right? According to our theory, according to the conclusion, the theories that we have learned about magnetic field lines or the direction of running of magnetic field lines. Okay, so this is how it looks like. Now you must have a question that so till when, like until when these field lines they will continue. Okay, the answer to this question, very specific answer to this question, is up to infinity. Now you must ask that if it extends up to infinity, then why the effect of this magnetic field we cannot feel if we are standing at a certain distance, right? So the effective distance, let me repeat this, the effective distance of the magnetic field lines are somewhat a few kilometers, a few hundred kilometers of it. Okay, but it never becomes zero. It never becomes zero. So the effect or the magnetic field lines, even far apart from each other, runs to infinity. Okay, now let us move on with our current topic to study. Let me just clear it up over here. Okay, yeah. This is a basic diagram, basic simulated diagram. It's, if you go to space and you won't see this, don't hold a grudge against me that you have told this is how the field lines are. Field lines, dear students, are always imaginary lines. Okay, they are always imaginary lines. Okay, now see, this is the main answer to your question. What happens is solar flares basically, we can say them charged particles. Okay, charged particles. Generally, we call them solar flares. So that's what caused disruption in our communication technologies also. Okay, so solar flares, they tend to rush towards Earth. Now, okay. Now, due to the nature of the magnetic field like this, okay, let us assume it to be like this. It's not a very good drawing, I know. Okay, let us assume it like this. Can you see that here at this point and here at this point, there is some gap between these two magnetic field lines? Can you see that? Between these two magnetic field lines, there always lies some minute gap over there. That is where these ions, these solar flares, they seep inside the atmosphere. Okay, the highly charged particles, they seep inside the atmosphere. All right, that is the main reason. And due to that, what happens? Due to that, what happens? Due to that, those charged particles or high energetic particles, they tend to react with the atmospheric oxygen. Okay, now this is where the color spectrum comes from. Okay, try to understand. This is where the color spectrum comes from. So you see, the red color is when it is occurring at this height. And why in this height? The presence of specific gases, the presence of specific temperature, the specific reaction conditions, that is where these colors come from. Okay, this is the most common color that we see during the phenomena of aurora borealis. Okay, now when it is reacting with atomic oxygen at high altitudes, above this 241 kilometers, okay, more than the distance, so there occurs the red colors. Okay, green is something around up to 241 kilometers, that means below the range of 241 kilometers we can see green. Okay, now when it is reacting with nitrogen till this height or above this height, then we get the pinkish kind of color, and finally we get the blue over here. So again, how can we conclude this phenomena? Due to the shape and due to the structure of the magnetic field lines, there lies some gap within the poles through which the solar flares or the charged ions or the charged particles seep inside the atmosphere, and due to the presence of atmospheric gases, specifically oxygen, okay, and other gases also like nitrogen, but specifically oxygen, these charged particles tend to react with those gases, excite those gases, and the excited energy state is released as light spectrum. That is it. That's why the beautiful phenomena of aurora is there. That is the also reason behind it. So I hope you have got the answer to this question. We'll definitely meet again with a new topic. Thank you very much.